Hello. Thank you very much. Thank you very much for coming here, and thanks a lot to organizers for inviting me. I'm pretty excited. So, as it was said, I'm Varya, and I'm going to talk about visual regression testings today. But I'm not going to talk about how to do it. I'm going to talk about how to do it. You will see the difference. So, anyone knows already about visual regression testing? Just raise your hands. Who uses it? Okay, I know one guy used to use it and gave up, and so he challenged me yesterday if I can change his mind. Let's see. So, well, we developers, besides coding, we dedicate very much of our time for hunting for bugs. Because, well, you know, it's always nice to catch something instead of being caught. And so we look for the bugs, and there are different techniques which helps us to do so. So, like pretty many of them are listed, and there are many others. Some are widely used, some not. But anyway, usually there are some testing approaches at the projects we are developing. But all the listed techniques, such as continuous integration and probably linting, like syntax linting for CSS, JS, even if all the tests are passed, it doesn't give the answer to the main question. And the main question is, does my website make sense to the user right now? Like, do they see like what they expected to see and what I was supposed to show them? Usually we find an answer to this question with different like manual approaches, not automatic. For example, we can open two browser windows with old version of the website and new version of the website, and then we visually try to match, like pixel by pixel, component by component, if it's the same. Especially if we haven't provided like actual new features or visual changes, but made some refactoring or such. And can you actually spot what is different here? Okay. But this is like doing this is pretty much about that. Really? Like we all mastered these skills in like reading kids magazines. And funny story, I was kind of pre-rehearsing the talk in front of my husband, who's also a web developer. And I showed him this slide just for 1 second. It was something like, blah, 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 kids magazines. And in 1 second, he was like, time is different, and the kitten has candy. This is because he is also a web developer. And he mastered, well, I'm sure he is mastering this skill every day, like we all do. But luckily, it's, which year it is? 2016. And now we have automation for that. This automation is called visual regression testing. So if you Google for his buzzwords, you can find what I mean. And I will introduce. So the idea is that you take a reference screenshot of your pages, for example, page by page, maybe from the production version of website, and you store these pictures somewhere, maybe even in the repository. And once you provide changes to the local copy, you may take screenshots again of the same pages and then compare this new image to the iconic image, to this reference image you have. And then you automatically see where is the difference. you either consider it bad if there is some difference, or you just pay attention in a particular sport to see if you if this change is, let's say, legal, if it's what you expected. So these are, again, these 2 pages. Yeah, it was guessed rightly that icon is wrong, but not only. And this, with such dips, we can see. So you see in pink, what's the difference? So there is something with the font, and it a little bit affects the button. And if I scroll down, you can see that, okay, the price, for example, in the last block, the price is used to be for month, is now for year. Then something with text, you can spot different icons, and so on and so on. Yeah. So this is how it works. But as with many other techniques, no, this flow is not enough, because it's always needed to use it in the right way so that it would help you. Let's see. For example, again, can you spot the difference? Well, I will say you that the header block is shifted 5 pixels. Well, there are some other differences, but this is what we should pay attention now. And now look at the visual difference. So it's like that, and I'll scroll down. Oh, wait. So now I scroll down, and it's complete mess. There are some other also changes, some of them unexpected, but we never know, because it's too many changes at the same page. And so this idea of paying attention into the problematic spot, it doesn't work with pages. But it works, yeah, it's impressive and useless. But it very well works with atomic approach. When you develop by components and when you test the single components rendered alone at the page, surprisingly. Let's see. So for example, the button has changed its size, and we can immediately see it. Like, let's say we do not have access to these first 2 images, but we can see it in the visual regression testing. The same works for alterated margin. Again, maybe not that easy to spot when you compare tab by tab switching, but easily seen right now. Missing icon fonts, or some broken order in Sprite, or something wrong with icons, so they are mixed. Then even the colors like that, they are slightly different. You probably will not see it if you work late, before deadline. It's almost the same. Yeah, and it also depends on our ability to see, to match colors. But regression testing is done by robots. And they do not care if they are slightly different or widely different. It's just different. This is the result. Also helps with typography. For example, if changing font, yeah, not that much difference, yeah? But you can see it right away. And how the typography may affect maybe some sizes of the other elements and such. So how we make it work? Obviously, we push our fellow developers to make separate page for a component, and once they make new component, they make page again, and they write tests for that, and having hundreds of components, they will write hundreds of tests. Yeah, I'm joking. No one will do this. But we still may achieve the goal by changing what we want. And actually, even before coming to these visual regression tests, I practiced a lot style guide approach. And I developed a tool called SC5 Style Guide, which parses CSS, SAS, OLS, and automatically generates a style guide for you. I usually give a separate talk about that, but it is very much related to the following thing, so I'm going to quickly show it. So the link you can see, this is the link to the style guide of my own blog, because I cannot share the style guides from my work, because it's like some other business thing, it's not open. But I usually bring the practices into my blog to be able to share the link and share the code on GitHub. So we are going to see it. So here it is, just a website. And this is the local copy. We will back to it later. And this is its style guide, like production version, and okay, the local version. So this is how this style guide looks like. So there is a page for every like block, for every component. Let's like say article. And there is a page for every component rendered separately, like in nothing else but this component. All the components are given the names. They are numbers, actually. This one is 3.1. But there are others. So there is like, let's say, 2.1. Now you see a header rendered separately, and so on and so on. So it's all, the tool is called SC5 Style Guide. It's open source tool. It's an NPM package. And in my code base, I have, let me show you. So I have CSS like that, like different components. They may fit into one CSS, it doesn't matter. I just divided them and store in folder. And here it is. So there are some comments which style guide reads and renders the site with them. And here is the actual CSS, and then it applies this CSS to the website, and you see generated style guide, which is generated right from the code. And if I provide changes, it rebuilds. So coming back to the presentation. Actually, the thing that this style guide is generated from the code with zero effort of me as a developer, and that it is always actual, like they call it living style guide, and that it has this separate page per component. It helps very much with introducing this visual regression testing technique. And to make it even simpler, I decided that I shouldn't write an article on how to do that and such, but I should make something like add-on to the existing style guide, which does it. And the add-on is like SC5 Style Guide Visual Test. It works only with SC5 Style Guide, but it works automatically. You do nothing but installing the package, and like Smoothie, Gulp, NPM, GitHub, all the buzzwords. And then if using Gulp, it's possible to make two tasks. First one is for taking like these initial reference screenshots. You run it once, and then you have like these images of every component. I can show you. So here it is. Actually, it is even possible to store in different dimensions, different browsers, but for the simplicity, I have it only in Chrome. This is why there is a folder and only one image in the folder. So here it is, like a language selector and some social icons, for example. And all the same for the other components. Okay. So this is what I gathered first when like running these tests, like making the reference screenshots. And then I have also a second task, which I run constantly, which compares my local copy to these stored reference screenshots. And it is just copy-paste from the documentation of this add-on for SF5 style guide. It doesn't even need any tuning. It is still possible to write complex tests and such, but it works right away after installation without any setup. So the result it gives goes like that in two variants. First variant is that one in console. So you see some tests passed, some not. These numbers are the names of the components, because FC5 style guide, it doesn't have the names of components like header, link, and such. It has the numbers for inheritance. But it's still, you know, the number you can navigate in the style guide website and see how the component looks right now. This can be used for some like automation, passed or not to pass. But from the broken tests, we do not actually see what exactly is the problem. We still need a human here, and it is possible to open a report generated locally and see like what gets broken. I'll show you at my website now. So, okay. This code, like I faked it, let's say that I'm using a library similar to Bootstrap, but something else. And these are the changes which came with new version of the library. I do not even check my website visually. I just like update the library. Hopefully it works. But actually, it provides changes like that. So you see the language switcher is too big because it's based on menu, and the menu gets bigger. But I can easily see it from the report. So here is this robotic way. So I see that something gets broken. And then I open this local HTML with the report. And I see, so this was the expected screenshot. This is what we got. And this is the difference. And then I can go back to style guide. So it was which component? It was 0.5. So let's go here. I go to 0.5. And I see it, and this is HTML. So I can open and like see CSS, and I can find out why it is so big. Okay. Where is it? So I think it's very nice because it's out-of-box solution. Because I developed that when I worked as a consultant. So I came to different teams to give them a tip how they should adjust their way of working. And it was very important to make them pay zero effort in the change, because they are busy. And they really do not have time to all these new techniques, implementing testing and such. But in here, it's just like installing package, and OK, you can practice this new technique right away. And yeah. And they do not even write any tests. It is possible to write a special test for a component because there is a lot of like features. You can make the component clickable, or you can ignore some dynamic parts. It's all possible. But important thing that by default you do not need to write any test. The default test is embedded into the tool. But custom tests are still possible. For example, you can test in different screen sizes. Especially, it helps when developing a responsive website, because it's a nightmare to check, like provide change, and then check it in all like with all the dimensions and such. But in here, it all goes like in the background automatically. Then it's possible to ignore dynamic parts. You just say which selector like not to pay attention to. And it is possible to wait for element to appear. For example, in my blog, there is one component which gets the list of my repositories from GitHub, and it obviously needs some time to ask GitHub API what is the list of repositories. And for such component, I made custom tests which waits a little bit. And you can make interactions, like, for example, clicking to the drop-down menu, waiting it. And it's possible to run any custom JavaScript inside it. So for the developer, using such a tool looks like that. So we can test particular component, like no need to test all of them all the time. If developing particular component, we can test it, or before release, or in continuous integration, it's possible to test everything, of course. When developing a new component, it's a good taste to create reference screenshot for it, so that like the others may test it later, and to see if they affect your new component. And if we provided like big refactoring, a lot of changes, we can just retake all the reference screenshots from production or from the local copy. Okay. And now it comes to stories. Because I did not invent this approach just thinking how good it could be. Everything goes with pain. And so the first story is that I was developing a pattern library in a pretty big company, and I was the only person making this library. But it was hundreds of components. And and releases were very often, because we wanted to bring it into practice for the new developers to accept the idea of pattern library, to show that it helps them. And the releases were very often, like several times a week, and it was just not possible that before every release I visually test every component, because there were hundreds, literally. It was a very big website. And once we changed, it was something with generating CSS from SAS, like we changed the engine for it or such. And but I checked some components, they looked okay. And so I released the library. And the developers of the website using the library were already waiting for the changes, because it was deadline or something. They took the new version of the library, and it worked perfectly well for them on the pages where they're developing. And then they released the website. But actually, it broke icon font. And but on this page, they were checking there was no icons, but there was no icons on selling pages. And it was not clear where is the cart, where to buy, like what to press to buy. And guess how we learned about that? like a big boss called to some lesser boss and asked why he cannot buy something from his web store. So we wrote everything back. But obviously, we should have the solution, because such mistakes, they wipe trust from the whole idea of the libraries. And so this is when I decided that we should have visual tests, and they should be the most automated, and they should check everything, literally every component. All the other stories are very good. Yeah. So after it was implemented, it made very good effect on the process of development. So we changed linking of the font, but this time being sure that nothing gets wrong. And we even provided some typography affection. And the person who proposed these typography changes was a little bit insecure, because you never know, like in this CSS, when you change something, if kitten dies or not. Yeah, but we were able to check it with these visual regression tests. And the whole culture of development went different, because we were refactoring more actively, and we provided better code, like being secure and feeling that something protects us. So obviously, it can be applied for continuous integration, and especially for continuous deployment, because I like this practice in theory, but I always feel nervous. How can I continually deploy? What if I break something? But visual tests should help a lot with that. And the interesting thing, also a very good benefit, removing the code, because CSS is declarative, and you never know if this particular line affects something or not. But with visual regression tests, you can remove this line and then check that, okay, it did not affect my website at all, or it did affect. So, and then you can adjust what to do. And as I said, intensive refactoring, which is a pleasure in itself. And the good also practice, which we made after that, is pictorial pull requests. So once providing changes to the component, and we contribute into the code base with pull requests, when we provide changes to the component to a page, we also include this reference screenshot into the same pull request, so that a reviewer may see what exactly are the changes. And it's very important that it's not a designer drew this thing, but it's actually generated from the browser. This is how this code works. Of course, it made some psychological changes over us. So before that, again, as I said, I felt a little bit insecure, because it's such a responsibility. We face customer right away, and even a small mistake can wipe their trust. And it is just not fair, and nothing protects us. Really? Well, there are pull requests and there are reviews, but they're still made by people, by humans, and humans make mistakes. This is obvious, and this is how it should be. But with visual regression tests, it helps with it. We feel safer, braver, and we can experiment and develop ourselves, our skills a lot, even with new technique, we feel more secure. For the businesses also works great, because this approach is very easy to sell for business people, because they understand that this is actually something which saves resources and money. And together with this visual regression tests, it is possible to sell this style guide approach. Because like many developers say that it is very good, but not all the business people understand why it's good, and it's not that easy to explain. But here, it's like very obvious benefit from that. So, thank you very much.